Hello everyone. Today we are going to discuss about microgrids. So the microgrids is a modern concept in power system. So these microgrid concepts basically tells the idea of having a local grid within the community. So the idea here is in locally we produce electricity. Locally means where the loads are located. So if you look at this diagram here, so this entire area is a local area. We call this local area where we have homes, generators, power generating resources. If you take one by one, we have the renewable energy resources here. We have a storage here. We have a diesel generator here. We have the loads, houses are there, and electric vehicles are there charging. So, what is the idea here? This entire system we have locally, we have a power generation, renewable energy, non-renewable, and this is non-renewable, and this is not renewable energy. We have a battery, we have a loads. So, all together we call the local grid. So, this creating this local grid is a meaning of microgrid, and we have the option to connect with the grid. So the idea here, this is a switch. Okay, this is a switch. So idea here is we are creating a local grid, and if we like, or if there is a requirement, if we are not generating enough electricity to supply these houses and the electric vehicles, our loads, basically our loads, then we can able to connect with the grid and get the help from the grid, or the we buy this the energy from the grid, buy the electricity from the grid. So this idea of microgrid basically is, we already used this system in 20 years before, 10 years before, in islands where the grids are not available. So if there is no grid available in the islands, then we usually have a diesel generators and small batteries, and with just a diesel generator and battery we provide the supply to the local houses, maybe 10 or 20 houses located in particular remote area. We provide the supply. So this simple concept now we are developing more because it provides the chance for renewable energy integration. If you look at the wind turbine and the solar PV, this is usually located in the within the community area, I mean the very local area. So these are easily can be integrated into the power system, rather than we sending this power uh, to the grid. We are directly using to the loads locally. So these are the renewable power generations, and we are directly using to the loads through the control. We have a control system. Through the controller we are using. So let's look at deeper, because it take a lot of time today's session, because it's a very important topic, as well as this is my PhD topic as well, microgrid reliability, modeling of microgrid reliability. So it's a very interesting type topic. It take more time, but for power engineers or electrical engineers, is a much needed topic. So uh, be with me. So look at here. This is a choice. Okay, we have a system. We have renewable energy resources, diesel generators, storage, and combined heat and power we can have, and the loads. So we are getting power from here, storage or anything, then supply to the loads. We are getting the power to the controller. So controller receive the power, and battery is charging and discharging. So both direction. Sometime we are giving, sometime we are charging. Okay. So what essentially if we need, we can connect with the grid. So idea is, if we need, we can connect with the grid. This is a switch. We have an option whether to connect with the grid or not. Okay, so this is the structure of the microgrid. So we can reject, I mean if there is no grid available, still we call this as a microgrid, but we call as a standalone microgrid. Let's assume there is no grid at all. As I said, the island or any other places, we don't have grid. So in that case we call this as a stand alone, because without grid, it's microgrid going to stand. So we call it stand alone microgrid. So we call it standalone microgrid. Microgrid we usually put MG. So these are microgrid, standalone microgrid. So let's continue. The definition of microgrid. Microgrids are localized energy grid that can operate independently or in conjunction with a larger power system. So it can operate independently. If it is fully independently operating, we call standalone mode. It's a locally running. Okay, injection we mean grid connected mode. Okay, they integrate various energy resources like solar, wind, gener and generators, diesel generators, and storage system. So we can have any power generation system together with a microgrid, and also we can have a storage. And microgrid are increasingly popular for improving energy security, reducing emissions, and enhancing power reliability. So energy security, reducing emissions, and enhancing power reliability. Because why we say reducing emission mean we can have as much as solar generation, power generation through this design, because we are going to generate the power and we are going to locally use it, especially in remote and disaster prone areas. Especially this microgrids are more appreciable or more applicable in the remote areas where we don't want to transmit the power for long distance, because we know that through the transmission a lot of energy losses happening. So transmission is a huge area where we losing our the energy losses are happening. So we no need the transmission. By doing this microgrid design, we are actually removing the transmission from the power system, because we usually have a transmission and distribution. Transmission mean, let's say we are carrying the power somewhere generated in a hydropower plant, we are carrying for 100 kilometers, that is transmission. Then after 100 kilometer we are distributing for 3 kilometer, that 3 kilometer is distribution. So here we are locally generating power in this 3 kilometer distance, the surrounded area, and we are going to use it. If really we need some issues coming, then we ask the help from the grid. So grid here work as a backup. Usually grid backup power grid, that is a microgrid. Okay, so key component of microgrid, what are the key component? Energy generation sources, we saw it that solar PV, wind power generation, storage, energy storage, battery energy storage, or any other different storage, and control system. We need to control this energy flow. So those are the things. Energy generation sources, so we can have renewable sources, solar, wind, small hydro, and commonly used in microgrids. These are the clean energy. So we are helping environment, we are protecting environment by integrating these energy resources in microgrid. And we can have a diesel generator as a backup. So in most of the microgrid, they have a diesel generator as a backup, because as we know, renewable energy resources are time based and highly depend on weather. So if any weather crisis or weather changes happen, then sometime we need to keep the diesel generator as a backup to give a power. Then we can have a combined heat and power, so CHP. So it's generate electricity capture using heat simultaneously, often used by industry. We know that CHP plant is usually use the heat byproduct from the industry. Industry running, heat is produced through the process of industry working. So that heat is used here as a power generator. That's what we call combined heat and energy. So waste heat is make it use through the combined heat and power generation. So this is also possible because factories are located in customer areas or local areas. If the factories are located in local areas, then combined heat and thermal power plant is possible. Okay. Then energy storage. When we come to energy storage, we have batteries. So batteries we commonly use lithium-ion batteries or flow batteries. So it's very simple. Everyone know about battery. Then we go for a thermal storage. We can store the excess energy as heat or cold as it is for cooling and heating application. We can have cooling, and in foreign countries, in cold countries, like there's a storage of heat, cooling storage. They store the heat and supply to the house, so that's is possible. Then the flywheels provide rapid energy release. So flywheels energy storage is when we release it, it releases rapid energy. So these are the energy storage mechanisms. Then come to control system. So we already studied about how we can generate locally generate electricity through the renewable energy resources or diesel power generation. We already studied how we can store the energy locally using batteries or any other flywheel mechanism. Now we are, we are studying about the control system, how we are going to control the power flow. So microgrid controller, that's a very important component. The central control system manages energy distribution, storage, and generation. It balances supply and demand, switches between grid connected and islanded mode, and ensures stable operation. So what essentially it does, it manages power generation, storage, distribution, and also it manages a switching between the grid connected and the island mode. Grid connected means we are connecting to the grid. So as I said, if our local power generation not enough to meet the demand, that's a supply and demand character, like a is a matter of meeting the demand. If we cannot meet the local demand, then we need to connect with the grid and use some energy from the grid to meet the demand. So that is a case. Another case, if we have excess power generation, in locally we create a lot of power, so excess power generation. So the whatever the excess, we want to sell it to grid. So in that case also we connect to the grid and we sell the power to the grid. So this is a grid connected mode. Where the islanded mode mean, if let's say grid is going off and on, or some issues in the grid, so that time grid is under repair or grid is poor, not reliable, that times we disconnect from the grid. One situation. Another situation, we have enough power generation to meet our demand, so we don't want to connect with the grid, so we can have a islanded modes operation. So these two modes are possible by switching between grid and microgrids. Okay, then smart inverters convert DC, so DC to AC. And we know that after studying solar PV system, we need to store energy in the battery. So also then from the battery we have to convert the stored energy into AC, then use it in the houses. So these smart inverters are important always. Then we have the energy management system. So energy management system optimizes the flow of power. So we need in the real time. So basically energy management system makes sure we are optimize the cost. So we don't want to waste our money by generating more electricity or something. So what is the essential idea is so energy management system makes sure with minimal cost we are satisfying the local demand. Okay, in case if we have our cost is exceed more than the grid's energy cost, kilowatt hour cost, sometime instead of generating we will buy from the grid. So it's all negotiation. Like if we can generate locally with a cheap price, so then we will generate locally. But in case the grid supply is less costly, then we will connect to grid and get the supply. And also other energy management aspects, like when we have to store in the battery, how long we have to store, when we have to get the energy from the battery. So these are the decisions. Okay, instead of connecting the grid, can we use our batteries? So there are a lot of decisions. So these all decisions made by energy management system. Then we have operating modes. We have two operating modes. This we already discussed: grid connected mode and islanded mode. Grid connected mode means is already connected with the grid. The system is connected with the grid. So this is a grid connected mode. In this mode, grid is participating in the energy supply. Grid together with the microgrid. This is a larger grid and our microgrid together. In islanded mode, only microgrid are participating in the energy supply, electricity supply. Grid connected mode. In the grid connected mode, microgrid operates in tandem with the main grid, drawing power from it when needed or feeding excess energy back to into the grid. It's like importing whenever needed, exporting when microgrid have excess power, or importing, exporting as based on the scenario situations. Okay, this is what is happening. Then ideal for area where the central grid is reliable. So if the grid is reliable, then it's better to have the grid connected mode, because we can sometimes grid electricity is cheaper. So in the off peak hours, grid electricity is cheaper. So those time we can import electricity from the grid. In peak hours, grid electricity expensive. That time, if we sell export some electricity to the grid, then they will pay much more amount, more money. So in this way, what microgrid become a business model where we locally generate electricity using solar PV, wind power generation, combined heat and thermal power plant, and diesel power generator. And whenever grid electricity cheaper, we buy from grid. Whenever grid electricity is expensive, then we will sell to grid and earn money. So this is a business model, becoming a business model. Okay. Then islanded mode. So islanded mode actually, the power microgrid is disconnected from the grid, main grid, completely disconnected from the main grid, either during outage or when energy costs are high. As I said, if the grid energy is expensive, then we disconnect. We don't want to buy from the grid, or buy mean import from the grid. It provides power during grid disturbances, enhancing resilience, especially for critical facilities like hospitals. So, islanded mode. What is a good in islanded mode? Let's say our main grid, we have a problem in the main grid. So, main grid going off and on for few times in an hour. So, there is some big issues going on. So, in that case, we can disconnect from the main grid. We can go for islanded mode. When we have hospitals and critical loads in our local area, we don't want the poor quality power to come to our hospitals. So, and also we need to protect the reliability of the power supply in this kind of situation. If when the main grid is not reliable, we better disconnect from the main grid and we supply to our own load when the loads are sensitive, like hospitals, some industry loads are sensitive. Okay, so and we need a reliable supply to the hospitals. Okay, so that's a good thing. So when now we are going to discuss about benefits of microgrid: improved reliability and resilience. Microgrid can continue operating independently during grid outages, ensuring power supply for critical facilities and reducing downtime. So this we already explained. I just read the thing. So they are especially valuable in disaster-prone areas and remote regions. Okay. So energy independence. Second advantage is energy independence. The local generation and storage reduces reliance on centralized power sources. So we are not rely on particular thermal power plant, or we are not rely on particular hydropower plant. So we rely on the local energy resources. So through the microgrid, we can have multiple local energy resources. I mean, resources mean power generating system, and we will rely on those. So, okay, so that will bring the energy independence. Microgrid reduce exposure to fluctuating grid energy prices and can be a source of stability for community. So community can, as I said, it can become a business model for the community. Community can earn money from these microgrid projects, and they can also save their electricity bills, because they can produce locally, so their electricity bills will reduce. On top of that, they can earn money by exporting to the grid. So environmental benefits. So microgrids can reduce greenhouse gas emissions by incorporating renewable energy resources and optimizing energy use. So as we know, with the microgrid concept, we can easily integrate solar power, wind power generation, such renewable energy resources. They support grid decarbonization and contribute to the lower carbon footprint. So carbon footprint is is a nowadays it's a famous topic. Like we want to reduce a carbon footprint in order to protect the heating of the earth. Okay, earth getting overheated and temperature rises is a big environmental issues. So in order to stop that, in order to reduce that, we need to go for decarbonization. So there's a net zero emission target. Everything is set in 2015. By 2050, the most of the countries in the world targeting to reach a net zero emission. It means like by 2050 they want all to produce power from renewable energy generation. Not only power, they don't want to produce any the carbon footprint. So this for this target or this aim, so this microgrid will help. Okay, we come to the last slide. I try to finish within 20 minutes, but unfortunately, a little bit goes more than that. Okay, we come to the last slide. That is a cost saving. By using local renewable resources and balancing demand with storage, microgrid can reduce energy cost, especially during peak times. I already said that during peak time, if you buy electricity or if you import electricity from the grid, we have to pay a lot of money because peak hours we have higher tariffs. So if you have a microgrid, we can locally produce electricity that can reduce our electricity bills. Simply, the community can benefit of saving cost. In grid-connected mode, microgrid can participate in demand response program, means earning revenue by adjusting usage according to the grid needs. So there is a program called demand response program. In this demand response program, we have a contract with the grid supply or electricity company. Company, whenever they have the lack of power generation, I mean they have a problem of generating enough electricity, that time they will ask us to shut down. Usually if you don't have a microgrid, they will ask us to shut down our loads. In this case, in microgrid case, they will ask us to disconnect from the microgrid. So if we agree on that disconnection, they will pay some incentives to us, okay? Because we are shutting down, actually in the meaning, we are shutting down the loads because we are disconnecting from the grid. Mean for grid do not have the burden of this community load. So we can have a demand response program. So and we can earn money through this microgrid development. Okay. So that's all for today. The my intention is to provide a brief summary about the microgrid. It's a simple concept, but it's a modern power system research area. Many people doing a research on microgrid because future we will have a number of microgrids, a lot of microgrids, because this modern concept of microgrid will enable more renewable energy integration and cost effective and environmental friendly. So because of these three reasons, microgrid adaptation is more and more faster in nowadays in the developed countries. In future it will come to developing countries as well. Thank you very much. Me see you in the next video.